Good morning. I'm Patrick Hollower with Bes-tech. Also here from Bes-tech is Dr. Liu. He's the CEO and founder of Bes-tech. What we are going to be presenting this morning is the Digi-Optimizer. The Digi-Optimizer is a method of increasing the overall efficiency for rooftop units and heat pumps. We're going to talk about the benefits of using the Digi-Optimizer, how it works, application areas, and we have some case studies, and there'll be some time for conclusions and questions. The main benefits of the rooftop optimizer and heat pumps reduces the electricity consumption significantly reduces the electricity demand, and it improves the space temperature performance and humidity control, improves the equipment lifespan, and reduces the equipment noise. Here's a pretty significant statistics. That is the amount of energy that is consumed by HVAC equipment. Rooftop units account for 60% of the cooling energy and nearly 33% of total heating and cooling energy in small and medium-sized low-rise buildings, primarily units that are less than 10 tons in capacity. For utility companies, this does have an effect on the overall energy consumed from the grid, obviously. Reduces the kilowatt energy consumption by up to 50%, and from the standpoint of utility companies, they don't have to generate as much electricity. For the consumer, reduces electricity consumption and costs, reduces the compressor cycling by up to 75%, therefore it will reduce the maintenance cost and improve the humidity control, and reduces the equipment noise in the conditioned space. This is sold as a package unit. The Digi-Optimizer applies to rooftop units and water source heat pumps. Now these are, when we're talking about rooftop units and water source heat pumps, obviously the rooftop units are air-cooled DX type systems. And we'll get into a little bit why this also increases efficiency of water source heat pumps. It does modulate both the compressor and fan speed based upon our patented technology, and it does not interrupt the existing control safeties of the equipment. Here's a case study. This is a rooftop unit. It's for a restaurant in Omaha, Nebraska. You can see there what the outside temperatures are designed for Omaha. These are the times when it was tested. You can see the temperature differences that we're looking at, the average, maximum, and the minimum. That applies to this. So you can see the number of cycles is the data sample of electricity demand, 1 month data sample. Now this is a 24-hour data sample. Look at the number of compressor cycles there. This is a look at the kilowatt-hour consumption, electrical consumption, comparison without the Digi-RTU and with the Digi-RTU. Here's a plot of the room temperatures, favorable information. And now this is looking at a water source heat pump. This particular is installed in a dormitory room in Bellevue, Nebraska, which is very near Omaha, Nebraska. Half-ton unit, 1 compressor. There's a look at the kilowatt demand, about half. Look at the room temperature comparisons, tracks very well. Actually, with the Digi-Optimizer, the room temperature is much more stable. Here's a look at the relative humidity comparison, very favorable with the Digi-Optimizer. Here's that same look with the water source heat pump energy consumption. Number of compressor cycles, water source heat pump, less than half. Cost and payback information, this is for Los Angeles. We just took a sample in Los Angeles. Conclusion, the Digi-Optimizer reduces the peak demand, reduces the energy consumption, reduce compressor cycling, reduce maintenance costs, improve room humidity control, and improve the room temperature control, and reduce equipment noise. I'll allow Dr. Liu and we'll answer any questions at this time.
How do you address the change in the outside air requirements if you're varying the fan speed on a rooftop unit?
There, Mike.
So to address the fresh air change, air change, typically, and overall, the air handling unit's operation, the total amount of air circulation is similar. It's because with the optimizer, the seasonal operation much longer time. That's number one. Number two, the fresh air intake for a building, typical light commercial building, is really dominated by how much the air be sucked out, which is the bathroom and fan, all those are the things. And we really did not see a significant change by changing the supply air fan speed for the fresh air. If this address your question. So we are talking about the units without an economizer. You with economizer, that's no issue.
No, but without an economizer, a rooftop unit set at a minimum outside air position in its damper. Slowing the supply fan down will reduce that amount of outside air. It is normally set already at the minimum position by required for code for the occupancy.
Right. So now, if that's an economizer, the controller will be adjust the position accordingly. Yeah. So if there is an economizer, you can say that, we deal with a lot of the units, like 4 tons, 5 tons, 6 tons. There was no economizer, simply a damper, a hole. That's all we have. So what's the payback? The payback is really depend on the utility rate. And our company operate across the country in a lot of Midwest operation and 4, 5 cents, 7 cents. So when we deal with 10 cents or so, we're talking about 4 or 5 years of payback, typically.
That's without incentives? With or without incentives?
Without incentive. And so with the incentive, typically we're talking about make the thing 1 year lower. And right now we are working with one larger company in San Francisco area, and we found out those.
What kind of end use? In San Francisco, you said?
Yeah, we are working with one company in Santa Rosa and the larger company.
An office sort of rooftop?
This is an industry facility. They have an office, they have a manufacturer, combined.
Okay.
Yeah.
Do you have third-party independent studies that you can make available to us?
So we have this, we're doing the proposal for the facility people, for the company, and sure we can share those reports with you. And
so would that proposal include a third-party verification?
And we typically work in the Bay Area. We have an office in San Jose area. So we work with, take advantage of PG&E program with applied material and JDSU third-party verification is what we're doing here. Yeah, the savings are verified by PG&E select the vendor and the third party and doing those.
Oh.
Yeah.
Okay.
Yeah.
All right. Any other questions?
So I noticed you're modulating the speed of the compressor as well as the fan.
Right.
I know in a lot of the compressor designs, the refrigerant flow is pretty critical for lubricating and cooling. Have you had any issues with compressor failure or reduced life for the compressor when you?
So we did this for several years on those, and typically 3 things we address through our patent technology. One is the oil return, and the second thing is vibration, because this machine designed for 60 hertz. When you're running at a lower hertz, actually, you could have a vibration. The vibration seems very subtle. However, it can make the leakage and the whole thing drain. You basically damage the whole thing. So what we have done, develop procedure, and so when we set up, we see which frequency we can work on, which we cannot. So those are the things. The second thing is, for the circulation, because of the oil return. So we have a certain way is we have a pattern. When this system operate, accumulate at a certain speed, and we will adjust the speed into a certain level, making sure we have the oil return to protect the compressor.
So you're actually doing that during the installation. You actually do a test and
Yeah, they say, yeah.
parameters based on that.
Right. So they say we have put this equipment in operation for the last 4 years. We continuously, monitoring every 5 minutes. Again, this is a Omaha Public Power, and they monitor this system. And every 5 minutes, we continue for the last 4 years. We put on right now cumulative like a 70 system there. And our data, really, in the very beginning, we did find, well, suddenly a couple of the things drained out. So because of vibration, the pipe leaking. But we addressed those things 3 years ago, all those things, and through those 4 years. And we really did not find anything like what we found 3 years ago.
So as a follow-up, I guess because it requires some proprietary installation, do you have contractors that you can train in order to do this? If we were to, I guess, is this product scalable, or are you going to have to be intimately involved in each installation?
This is a box. Basically, we provide a box, we provide the training, we provide the technical material there. So now the installer will get a week-long training, so they will be able to install it. Yeah.
So it looks like you did a lot of work with Omaha Power. Was there a report done from them?
Yes, sir. So first of all, so last year, so Omaha Public Power run a program, and it's about 20 machines, and we dedicate for those. After 1 year testing, OPPD did those. So that project was rewarded one of the 2 awards from Public Power Association, American Public Power Association, and they got an award. So I feel good about those. Yeah. Sure, yeah, definitely we will do those, yeah.
Do you have a sweet spot for the equipment size that you like to to install?
Definitely, sir. So really, 10 tons around, that's the best, but you can go as low as 4 tons. So 10 to 15, that's the best. And you can get a payback 2 or 3 years. But 4 or 5 years, 4 or 5 tons, 4 or 5 years. So when we typically work for the large Fortune 500 company. They have a facility, like right now, the facility they have in Connecticut, they have in New Jersey, they have in California. We integrate all those in together, and the small ones, the larger ones, 3 years of payback. So we give it to them. That's how we work.
If you could go back to that temperature graph for a minute, more than a second. There we go.
Okay.
Explain this to me, because this raises skepticism to me. It looks like the room or the restaurant was warmer, the green line, right?
Right.
On the day you ran your optimizer versus the red line, which would imply to me that you needed less energy to use because you kept it at a 2 degree higher temperature.
So that's very true if you look at those things, because we're looking at really the whole year data. So our engineer just put in this case, is higher. But what we also have the data which shows the entire year against the outside air temperature. And we compare with, for the whole year, what is before, what after. If you want to get the report, we will more than happy to share with you.
Well, I didn't put up this graph, you did, right?
Yeah.
So on this day, you have the 24-hour consumption for the red day and the green day.
So actually,
how did that compare?
0 to 6 o'clock, the system was off. You can see those, the things for these specific things. You see the timer is actually floating. Yeah.
Okay.
Yeah. Please.
Yeah, just a comment on this particular graph. It might be best to plot the ambient temperature versus the internal temperature, because I think the previous slide shows that the ambient temperature was warmer during the with optimizer testing, or maybe it was a slide after, because they were moving around a lot during the presentation.
So I think that's for that specific day, because my engineer she has a habit of want to pick up
Yeah,
on
here
that.
it is. With the optimizer, it was 2 degrees warmer ambient at the average.
Right. It's very hard. It's very hard to slide that day exact same. I mean, right.
Just a comment. Thanks.
Right. Yeah. Very hard to.
I think just as one last comment on this issue, for that slide where he showed the temperature fluctuating, I think it's important to put it in context with a set point inside the building, because if you're holding the set point more accurately, I think that savings can be considered as actual savings. Where if without that context of the set point, it does show you're providing less cooling, so it's kind of a.
This is not a lab test, and there's a lot of variation. What we really can share with you for the whole entire year comparison, and you will see under all different temperature, you can clearly see 30 to 50% savings over 40 units. And we have all those data, but this does not allow us to show everything. Thank you. Yeah.
Thank you.